Good morning, guys and gals. Today we're going to be solving problems with unit rates. Yesterday we went through and we worked problems 5 through 12, and then you were supposed to complete problems 13 through 16 for your homework. If you have not completed 13 through 16 for your homework, you need to make sure that you complete those today. Today's objective is that we're going to identify the constant of proportionality from graphs, tables, equations, and verbal descriptions. And we're going to use rates and proportional reasoning to solve real world problems, including scaling two-dimensional objects. So to get started, what we're going to do is I'm going to start with a few opening questions. And so I want you to think about if we had this picture right here. And so, say that we wanted to enlarge this image without changing the way that it looks. What would we have to do that? So, think about that for a second. How would we enlarge this photo? What would we need to do with the length and the width? How could we use those to enlarge this photo? And think about if we were to triple this. If we wanted to triple the size of this image, how could we triple it? What would we have to do to the length and the width? Okay, so by now, you should know that whatever the original width and length are, we're going to have to do what type of operation? We're going to have to multiply. So we would take the original height and the original length and we would multiply them both by 3. And that would give us a new enlarged image that's proportional to this image. So, how could we find the ratio's simplest form? Say, for instance, that our picture is 2 inches in height by 4 inches in width. What could we do to determine what it would be in its simplest form? All right, so thinking about that, we could either divide 2 and 4 by 2 to get 1/2, or we could take 2 and multiply it by 1/2 and get 1. We could take 4 and multiply by 1/2 as well to get 2. So that would give us our simplest form, or in that case, our unit rate. Because remember, unit rate means we're comparing part of a ratio to 1. All right, so to get started, we're going to start with looking at page 1. So in this activity, we're going to revisit another kind of problem that we've studied before. And as we explore, we're going to look for the unit rate in the situation. So it says, suppose you use your camera to take a close-up picture of a giraffe at the animal park. All right, so looking at this, you should notice that the height of the photo is 3 inches and the width of the photo is 4 inches. And the camera shot makes the photo into posters with a width of 12 inches. So what will be the height of the poster? If the new width is 12 inches, what would the height be? So I want you to think about, what are they enlarging this photo by if the new width is 12 inches? In other words, what are they multiplying 4 by to become 12? And if we know what we multiply 4 by to become 12, then what can we do with 3 and whatever that number is to determine the new height? All right, so looking at this, you'll notice that they have graphed our picture. And what we're going to do is we're going to try to figure out a few ordered pairs to see how this is changing. So if you notice right here, the height, once again, is 3 inches and the width is 4 inches. So let's see what happens when we change the size. So right now, what I want you to notice is that our ordered pair for this one would be 4 to 3 because the ordered pair is X to Y. And that's how we graph. So in this case, we go from 0 to 4, and then we would go up 3 on our Y. And so our ordered pair is 4 to 3. So let's see what the next ordered pair would be. All right, so here you notice that our ordered pair changed and the height increased by 1 inch and the width increased by 1 point what inches? 1.333. All right, so let's see what happens next time. So once again, we're still increasing. We're increasing by an inch in height. And every time we increase by an inch in height, we're increasing by 1.333 inches in width. So you'll notice down there at the bottom in the yellow, it says when the picture is changed proportionally, a line is passing through the origin. And so if you don't know what the origin is, that's actually this point right here. So that's the point 0, 0 on a graph. And so when they say it's passing through it, what you need to imagine is this line right here is carrying through that origin. All right. And notice that it is a straight line. Since it's a straight line that passes through the origin, this is a proportional relationship. All right, let's see what happens if we get some more ordered pairs. Look at this one. So our next ordered pair that shows a actual whole number is 6 to 8. Is that right? Look at that real close. I said that X has to come before Y. Is X coming before Y here? No, X is not coming before Y. So that means we have to reverse these. All right, because X always comes first. So X, once again, we start at 0 and we go to the right to 8. And our Y, we're going to count up to our Y. 1, 2, 3, 4, 5, 6 is 6. All right, let's see if we can find another ordered pair that has to do with a whole number. Or you could think, how could I come up with another ordered pair? What is 4 and 3 both being multiplied by to get 8 and 6? 2. 4 times 2 is 8, and 3 times 2 is 6. All right, so let's take a look and see if we can find another whole number. Well, that's not a whole number, but our width is a whole number, and our height is 7.5. All right, so let's see. There's another one. So what did they multiply 4 by to become 12? And what's 3 being multiplied by to become 9? While you think about that, I'm going to write the order pair down. So remember, our X comes first, which is 12, and our Y is second, which is 9. So by this time, we should know that 3 times 3 is 9, and 4 times 3 is 12. So that's how we create proportional ratios. And you'll see that using this graph, we're able to determine proportional ratios just as well as using multiplication to create proportional ratios. Because once again, if a line passes through the origin and it's a straight line, then that is a proportional relationship. So every ordered pair on this graph is proportional to our original image, which was a 3-inch tall by 4-inch wide photo. All right, let me get this erased off of here real quick. And we'll watch this. So it says now you can use a table to look at the ratio of the heights to the widths. So remember, these are the heights and widths that we just looked over. All right, that's what we did whenever we were moving the table left to right. Okay, so looking at this, what we're going to do is we're going to take this and we're going to watch the video. Okay, so looking at this, what we should see is that in order to find out if this is a proportional relationship, they had to determine a constant of proportionality. And so to find the constant of proportionality, what we're doing is y divided by x to find our constant. All right, constant of proportionality is represented with a k. So y divided by x equals k. So in this case, you'll notice that 3 divided by 4 equals 75 hundredths. 3 and 75 hundredths divided by 5 equals 75 hundredths. 5 and 25 hundredths divided by 7 equals 75 hundredths. And 6 and 375 thousandths divided by 8.5 or 8 and 5 tenths equals 75 hundredths as well. So what you should notice is that since every one of these are alike, we have a constant of proportionality. So, looking at what the yellow box or yellow rectangle says to us, it tells us that we should notice that the table shows a set of equivalent ratios of height to width. And so, since that occurs, there's an associated rate of unit of height per unit of width. And so we know that the numerical portion of this rate is called the constant of proportionality because that's what we just found by doing y divided by x. So it's letting us know that we can also find the constant of proportionality from the graph. So it says to find the constant of proportionality from a graph, find the quotient of a y coordinate and the corresponding x coordinate, and then drag the point to see that the constant of proportionality for different points on the line stays the same. So if we do this, if we take this amount and we drag it each time, notice how our k, which is right here, is going to stay the same for every one of these ordered pairs on our line. Notice how each one that we divide y divided by x, for every time that we do y divided by x, as long as we're on this perfectly straight line that passes through the origin, we know that we have a constant of proportionality. And this is representing a proportional relationship. So therefore, each one of these that we do y divided by x on this line that we've graphed is going to have the same constant of 75 hundredths. So looking at this, it says in the activity, we're going to revisit another kind of problem that we've studied before. As you explore, look for the unit rate in this situation. That was what it wanted us to do at the very beginning. So remember, to find the unit rate, what we're doing is one part of the ratio has to be compared to 1. So in this case, in order for us to find that, what we've already done is we found the unit rate by doing y divided by x. So what we should understand is that the unit rate is equal to the constant of proportionality. So looking at this, they were able to find the actual point on the graph by saying that when we get to 1 inch of width, that is equal to 0.75 inches of height. And so anytime that we want to find the unit rate on a graph, all we have to do is make x 1 and find y. All right. Or if we wanted to find the width to the height instead of the height to the width, we would say go to 1 on the y and see where your x lies. So it says, notice that when x equals 1, the y value on the graph is the constant of proportionality. The unit rate is the height for a width of 1 inch. The unit rate is the height for a width of 1 inch. Now, using this information that we've done on the page 1, going through these 5 parts, we should have been able to answer question 1, A through B, and question 1C. So if you have not answered these questions, you need to answer those now in your workbook. Okay, so page 2, it says in the giraffe photo enlargement problem, there's a unit rate of 3/4 inch of height per 1 inch of width in each of the enlargements. We say that the heights of the photos are proportional to the widths of the photos, and there's a proportional relationship between the heights and the widths of each enlarged photo. For this reason, the numerical portion of the unit rate is called the constant of proportionality. So it says that the unit rate equals 3 divided by 4, or in our case, we know that that means 3/4 of an inch in height is equal to 1 inch of width. Or in other words, we can say 3/4 inch of height per inch of width. So that means that every time we have an additional inch in width, so say it gets wider, every time that it gets a little bit wider, little bit wider, little bit wider, that means there's also going to be 3/4 of an inch taller each time. All right, so therefore we know that the constant of proportionality is 3/4 or 75 hundredths. So let's look at page 3. All right, so looking at page 3, it says that in the giraffe photo situation, you can write an equation to represent the relationship between the height and width of the photograph. And the height equals the constant of proportionality, 3/4 times the width. Using h for the height and w for the width, you can write h equals 3/4 times the width. So that means to find the height, we're going to do 3/4 times any width, and we'll be able to find the height. So it says now use the equation to solve a related problem. So looking at this problem, it says the camera shop makes photos and posters with a width of 12 inches. You want them to enlarge your photo to make a poster. So how do we find the height of the poster? So we want to do this using the equation. Now, I know most of us have already learned how to use mathematical reasoning, and we know that if they did 4 times 3 to get 12, we can do 3 times 3 to get 9. Well, we're going to basically do the same thing, but we're going to solve for h by taking 3/4 and multiplying it by our width. So if we do 3/4 times 12, we know that 12 times 3 equals 36, over our denominator, which is 4. And we know that 36 divided into 4 parts is 9. Ooh, that's an ugly 9. Is 9. So let's check our answer and see if they did it the same way that we did. All right, so looking at this, it says the height equals constant of proportionality times the width. So they did 3/4 times 12, and they got 9 inches. And that is exactly what we did. Now, for those of us that like to do it the other way, remember, we took the original 3/4 and we set it equal to something over 12. Well, we don't know what that is. We can find the scale factor. We know that 4 times 3 equals 12, so we can do 3 times 3 and get our answer for x, which is 9. And this is the same answer as this. So it's good to know how to work it both ways. Okay, let's take a look at page 4. All right, looking at page 4. It says here's a more challenging giraffe problem. So they didn't think we were working hard enough. So now we're going to try to work a little harder and see if we can still get this right. So it says the photograph is 4 inches wide and represents 16 feet in actual distance. So remember, that's like using a scale factor for a map or a drawing. So it's telling us that this actually 4 inches represents 16 feet. Okay. So if that's the case, then how do we figure out the actual height of the giraffe? Because you notice his feet are at the bottom of the photo and his, I don't know what if those are antlers or horns, but the top of his head is at the top of the photo. All right. So looking at this, what can we do to find this? There's 2 ways we can do it. But notice it wants us to write an equation. So remember a while ago, we know that h equals what times what. So what was the constant of proportionality? Remember, the constant is when we do y divided by x to get k. And k is our constant of proportionality. So remember that this is y and this is x. X is our horizontal axis, y is our vertical axis. So if we do 3 divided by 4, that equals our constant of proportionality, or our k. Okay? So with that being said, h, which is our height, is equal to our constant of proportionality, which we know is 3/4. So we put 3/4 here, and we know we need to multiply it by what? What could we multiply it by? So you'll notice that I did 3/4 times 192 inches. Well, how did I get 192 inches? So think about this. We know that each one of these represents what? How would I figure out how much 1 inch represents? Could we find the unit rate? So remember, if we were to find the unit rate, we could take what? 4 and 16 and see what we're actually coming up with. So if we were to do that, we know that 16 and 4, if we do both of those divided by 4, that would tell us that 1 inch is equal to 4 feet. So since 1 inch is equal to 4 feet, I know that if I take and find out how many feet I would get for 3 inches, I know that 3 times 4 would be 12 feet, right? So I have to figure out what number would I multiply by 3/4 to be able to get 12 feet. I know that 12 feet converted to inches is 144 inches. So I know that I have to find a number that is larger than 144. And so the only option that I have here is 192. So I'm going to work this in our calculator just to show you how this works. So if we do 3 divided by 4, we're going to get 75 hundredths. And if I multiply that by 192, I get 144 inches, which would equal how many feet? 12 feet. All right, let's see if there's another way we could solve this. All right, so we've reset the problem. So let's see if there's another way we could get this. What could we do to try to figure out how many feet we could get? So once again, if I took our 3/4 of our 3/4, which is our constant of proportionality, and I multiply it by a number, what number would I multiply it by to determine my feet? In other words, what times 3/4 equals 12 feet? 16. So let's take 16. 16 divided by 4 is 4, and 4 times 3 is 12. So 16 would work as well. So there's two ways to do that. We can either work with feet or we can work with inches. So those are two ways that we can solve that answer. Now remember that this is going to answer that question we just worked on is going to answer your question in question 3 in your workbook. And so we had two ways that we could do that. So we could solve to find the height of the giraffe by looking for an answer that would yield us 144 inches, or we could try to find an answer that would result in 12 feet. And so both of those work with using our constant of proportionality, which was 3/4 or 75 hundredths. So on pages 5 through 6, we're basically going to think of a second unit rate that we could write related to the giraffe poster problem. And so I want you to consider what kind of questions we could answer with using these unit rates. All right, so look at this. It says, in the photograph of the giraffe, the ratio of the height to width is 3 inches to 4 inches. We've been working with the associated unit rate of 3/4 inch of height per inch of width. And so it says you use the related constant of proportionality, 3/4, but remember that every ratio has two associated rates. And that's what we were talking about earlier whenever I said you could rotate our y and our x and our x and our y. And so it says, what other unit rate could you write for the given ratio? Well, we know that if we take our width and divide it by our height, that will give us our width per inch. So we know that our width per inch would be 4/3 of width in inches to every 1 inch in height. So it says, what kind of question can you answer using this unit rate? And how's the question different from the one on the previous page? Well, we're comparing our width to 1 inch of height, whereas before we were comparing our 1 inch of width to our 3/4 of an inch in height. And so that is how the question is different from the ones in the previous page. So let's check what they have. So looking at this, just like we said that 4/3 inches of width per inch of height. So it says this is another unit rate associated with this situation. And so if we convert 4/3 to a mixed number, we know that 4/3 is 1 1/3 inches of width for every 1 inch of height. So we're going to solve a puzzle on page 6 to see what kind of question we can answer using this unit rate. So looking at page 6, it says, suppose we want to enlarge the 4-inch by 3-inch photograph of the giraffe. We want to make a poster that has a height of 48 inches. And we want to determine what the width of the poster will be. So it says drag tiles to write an equation that we could use to answer this question. And then we're going to solve the equation to find the actual width of the poster. It says, notice that you are now looking for a width, not a height. So what unit rate and associated constant of proportionality do we need to use in order to calculate the width? So remember, a while ago, we found the new constant of proportionality, which is the width per 1 inch of height. And so to find that, we had to take our x, which was our width, and divide it by our y to create that other associated constant of proportionality, or our other unit rate. To do that, we did 4/3 to 1 inch in height. So it says W, which is our width, equals W inches. All right. So W, remember, is our width, equals what times what? So I want to show you something. If Y equals our constant times X, which is our height, X is our width. So how can I solve for X? What would I need to do? I would need to divide by K or multiply by its reciprocal. So Y divided by K would equal X. Since Y divided by K equals X, we're going to use this knowledge to solve this problem. So it says W equals something times something. So remember, it says that the new height is 48 inches. So what would we do to find the new width? Well, what times 3 equals 48? Is it 12 times 3? 12 times 3 is what? 36. So what's 12 times 4? 12 times 4 is 48, but we can't do that. So that means we're looking for a number that is larger than 12. So looking at these, we could say what? We have 3/4, we have 36, we have 4/3, we have 48, we got 16/3, and we got 64. So what can we do to determine our new width? Well, let's take what we have. We know, okay, so in answering this problem, remember that our constant of proportionality is 4/3. So what we need to do is we need to take 4/3 and we need to multiply it by the number of inches that we already have. We know that the number of inches that we already had for our height is 48 inches. So we want to take 48 inches and multiply it by 4/3. So if we want to do that in a calculator, we can take our calculator and we can do 4 divided by 3. And then we can multiply this by 48. And that lets us know that our new width is how many inches? 64 inches. Great job. All right. So remember that you have to pay close attention to detail because if you don't, you can mess. So that right there is how we use this to answer question 4 and question 5 on our workbook. So in closing to today's lesson, I'm going to have a couple HOTS questions. And what I want you to do is I want you to discuss with your classmates how this would work. If you're in a virtual classroom, I want you just to think about this. Think about how this would work. How could you answer this question? Measure the length and the width of a book in the classroom, or measure a book at home, the length and the width. Once you do that, I want you to try to find the constant of proportionality. So, what is the constant of proportionality of length to width? And then what I want you to do is I want you to double the length, and I want you to use the constant to find the width using a an equation just like we've done in class. So, for our work in class and for homework, if we're unable to complete this, what I want you to do right now is I want you to complete questions 6 through 9 in your workbook. And after you complete questions 6 through 9 in your workbook, I want you to complete question 17 in more practice. So I want you to do that now, and I will see y'all tomorrow. Have a great day.